You guys, the words right next to it. Can you guys? Rate of change is slope. It's the same thing. It's basically the change in y over the change in x. You guys, do you remember how to find the slope? If I give you 2 points? The slope, we'll talk about that. So it's the change in y over the change in x. So that's what we're going to focus on. So we're going to look at this problem, and we're going to talk about the change in y over the change in x. Okay. You guys... Okay, so the graph shows the number of gallons of water in a swimming pool as is being filled at the rate is the pool being filled. At what rate is the pool being filled? Okay, so the change in y. So the change in y is going up or down. So I always like to go up and over. So we're going to go up 1, 2, 3, 4. Okay, so I don't like these type of problems because you should be able to count if you haven't. So we're just going to use the slope formula. So the change in y, so we're going to take the changes in y's. Remember, this is xy, this is xy. So it would be the change in y over the change in x. So it's basically 252 minus 108. And then it is 7 minus 3. You guys remember, I always use the bigger numbers, and I was going to go up and over. So if I was going to go up to this point, you guys, and over, so that's up and to the right, that means my slope should be positive. If I went down and to the left, it would be a negative or a negative, which still would be positive. So 252 minus 108. 252 minus 108. 7 minus 3. Now, because we're talking about the rate of change, we really are going to have to reduce this. So does 4 go into 144? So 36, right? So 144 over 4 is 36. So how we would say that is change in y, right? So what rate is the pool being filled? So it's 30 gallons per what? 36 gallons per what? Per minute. Because it'd be 36 over 1, and because it's the change in y over the change in x, the change in y is water in gallons, and you could put 30 gallons of water per minute, and then your x is the time, so that's why it's per minute. So it's really important when you're talking about rate of change that you put those measurements on there. What does it actually mean? So you have to pay attention to your y and your x. With slope, you don't have to put measurements on it because it's just your rise over your run. But for rate of change always has measurements, okay? So in 2002, 23,142 students applied to State College and 34,689 students applied to Central University. In 2010, 29,563 students applied to State College and 36,107 applied to Central University. Determine the average rate of change in applicants for both schools in 2002 to 2010. Okay, so it wants to talk about the rate of change in applicants. So what do you think is going to be in our numerator? What numbers are going to be in our numerators? The year or the applicants? What? The applicants. So we're going to do state. So we're going to do in both schools. So we have two schools. You can't do both. So we're going to do the state college. So state college, right? So how many applied to state college? And we're always going to start with 2010. So how many applied to state college in 2010? There we go. And how many applied in 2002? 23,142 minus 2002. Notice, you guys, when I put the 29,563, that was in 2010. There was 23,142 in 2002 for the state college. And now we're going to subtract. So what you guys got? Over 8? Okay. And when you divide it, you get about, roughly, right? 802.625. That's what I got. So we can round up. So it's approximately what? So the rate of change, to determine the average rate of change in applicants for both schools. So there's approximately 803 applicants every, well, when we reduce this, this becomes 1, so every year. So the average rate of change in applicants from is about 802. Now, do you want to do the next one? I'm not going to do the next one. I think you guys got that. Let's move on. Oh, you don't. Let's go to the next page. You guys don't have to flip it. You know, I flip mine. I make it so that I can get a better detail for you. Now, you guys, that's rate of change. And you know what? Oh, I forgot to put, remember I told you. So the average rate of change in the applicants for both schools from 2010 is about 803 applicants. Okay. Now we're going to go here, bless you. And we are going to do some slope. Okay. Remember, it's y2 minus y1 over x2 minus x1. You guys, the first ordered pair you see is always your x1, y1. The second ordered pair you see is always x2, y2. So 5 minus negative 3 over 3 minus 1. In an equation, you would write slope as just 4x, right? And if you're just giving me the slope, I want you to leave it as a fraction, as 4 over 1, because that really is telling you rise over run. Okay, let's do 3b. So negative 9 minus 11 over 24 minus negative 8. You guys notice that these two numbers come from the same ordered pair. These two numbers come from the same ordered pair. What is negative 9 minus 11? And this becomes positive, positive, and so this is, and then we should always reduce your slope. So your slope should always be in simplest form, always. So it doesn't matter if it's One thing that I think the SAT likes to do is they do like to see if you can find equivalent SATs, equivalent slopes, okay? Can I give you a slope and can you find other slopes that are like it? So what would I reduce both of these by? And I would get -5/8. Okay, so that means so from whatever my starting point is or from wherever I am, I would go down 5 to the right 8. Whatever point that I start at, okay, I would go down 5/8. So slope is constant. The slope of a line is the same no matter what 2 points in the line are used. You guys, you don't have to start at the y-intercept. You could just start at a point on the line and then go up or down, right, left, what you need to do. Okay, so number 4A. Now it's asking you to find the slope. So what I do, you guys, is I find 2 points that are on the line. And what I mean by that actually cross at a specific spot. That one crosses, this one crosses. So remember, when you do this, you either go down and to the right, you either go up or down first, left or right. So I'm going to go up. So I'm going to start here. And this is, you guys look, it's counting by 2. So this is 2, 4. So this is 2, 4, 6. And because I went up, it's positive. And then I'm going over. So 2, 4, 6, 8, 10, 12, 14, 16. Did I count that right? Did I count that right, you guys? Did I go over 2 and... Okay, so again, you need to reduce it. And you guys, because I went up, that's why it's positive. Because I went to the right, it's positive. And now I need to reduce it. I can reduce it by 2. 6 divided by 2 is 3. 16 divided by 2 is 8. So my slope of this line is 3/8. But you notice that graphing 3/8 on this graph would be difficult because you can't just go up 3, right? Because it's being counted by 2s. So sometimes that's why we make equivalent slopes.